Hello everyone, this is Rajesh Pichaimani and I'm a solutions architect at Amazon Web Services. In this session, I'm joined with three of my colleagues and friends, Chintan Patel, solutions architect, Ramesh Chitirala and Pradeep Sridharan, senior solutions architect from my team, in presenting you on the topic of building MCP servers with Amazon QCLI, and this is done using the Rust programming language. So let's get this started here. We'll start with the MCP server workshop overview, and there are 4 labs that we will be walking you through in just a second, and finally conclude with the references. This is the workshop, and the QR code to access the workshop is listed in the top right screen. As I mentioned, there are 4 different labs in this workshop. The calculator server will be hosted by Pradeep. This performs various mathematical calculations using natural language. The second lab, RDS operator server, will be hosted by Ramesh Chitirala, and this lab will help to walk you through the RDS operator server to interact with various RDS instances across the regions. The third lab will be hosted by Chintan Patel, the S3 operator server, with examples to interact with various S3 buckets. Last but not the least, the lab 4, the Postgres operator server. I'll be walking you through the examples to query the database tables using natural language without using any SQL queries. Lab 1, calculator server. Over to you, Pradeep.
Hello all, my name is Pradeep Sridharan. I'm a solutions architect at Amazon Web Services, and today I'll be walking you through the Lab 1 calculator server of the workshop Building MCP Servers with Amazon QCLI and Rust programming. Now, before we get into the detail of the Lab 1, let's try and understand what MCP is. MCP, or Model Context Protocol, is an open standard that enables AI models to create and access external data, tools, and services in a standardized way. The common example given is think of it as a universal plug and play system for a application similar to USB-C, right? Uh, it kind of provides a standardized interface for different models to talk to different tools. Now, Lab 1 will be building a really simple calculator server. This demonstrates how easy it is to build a MCP server. In subsequent labs, we'll be covering more advanced concepts. So this lab breaks down into several key components. We'll first look at the code structure. Then we'll go through the building processes. Then we'll look at the integration steps to integrate with Amazon's QDev. And then we'll do some testing. Let's go into the code. The Rust code that sets up this calculator server is fairly straightforward. You have a section that covers the import side of things. It imports all the necessary libraries. And then we have a setup for a few structures that outlines some functions, some request, and calculator. Then we have a tool implementation that implements those functions, particularly the MCP tools for sub and sum. And then we'll have a server handler and a main function. It's fairly straightforward, nothing complicated here. Let's go ahead and start doing the building process. Now, let's first cd into the source file directory. Now, once there, we can execute the build command in the release mode. I have already built it once, so this will actually conclude quite fast for me, but it might take a while for you when you run it first time. And once it's built, we can also look at if the build was successful. I mean, just double checking. Yes. So now that we have built the MCP server, let's go ahead and integrate it with Amazon QCLI. We'll start this by creating the mcp.json file. So I have, you know, gotten into the text editor. Now let's add the configuration here. And, because this is a VI-based text editor, you can actually exit by doing WQ. So this configuration registers a new MCP server with the name calculator and specifies the path for the executable, does not provide any additional argument. Now let's test the calculator MCP server. For this, we'll have to start a session with QCLI. The command for that is qchat. If you have not done before, you may have to do a q login to get into the QCLI, but after that you can just directly start chatting using qchat. Let's see. Can you add 42 and 58 using calculator? So obviously Q need not use the calculator to add 42 and 55, but this is since a simple demonstration. And you can see that the Q is using tool sum to add 42 and 58. Yeah. Use T to trust. I'm going to always allow. Yeah, and you can see that this was performed using the MCP calculator. You can also look at subtraction just to test it out as well. Again, I'm going to choose T. Yeah, you can see that it kind of works out. And obviously, this is fairly straightforward. But how does it actually work? When you ask Amazon Q to perform a calculation, Amazon Q recognizes that it can use the calculator MCP server for this task. This is based on the configuration we have created. It starts the calculator server processes using the command specified in mcp.json. Then it sends a request with appropriate parameters. The server processes and returns the results, and then Amazon Q presents the results back to you. Now, this demonstrates the power of MCP servers. You can use it to extend the capabilities of Amazon Q and also wherever applicable to be able to orchestrate multiple agents or external services or tools and provide services that could combine all of them. Thank you and have a good day.
Hi, I'm Ramesh Chidirala, a solutions architect working at AWS, and I'll be walking through Lab 2 of this workshop, where we will be building an RDS operator MCP server. This MCP server enables users to interact with Amazon Relational Database Service. This would allow Amazon QCLI to query and manage RDS instances using natural language commands. For instance, you will be able to list all RDS instances in a region or retrieve data from the tables by simply asking questions in plain English. The RDS operator MCP server uses AWS SDK for Rust to interact with Amazon RDS. Let's review the key components of the server. The code imports AWS SDK components along with the Rust MCP dependencies. It then defines data structures to hold information about a single RDS instance and a container to hold a list of RDS instances. It then defines the RDS operator structure to hold AWS SDK information and provides methods to create RDS clients for specific regions. It then implements a tool to list RDS instances in a specified region and handles errors gracefully. The server handler implementation provides server information and enables tool functionality. And finally, it all comes together in the main function, which sets up logging, creates a new RDS operator instance, starts the MCP server, and waits for the service to complete. Now that you understand the code, let's build the RDS operator MCP server. Navigate to the sample code directory and build the server in release mode. This command will compile the RDS server with all its dependencies and create an executable binary in the target release RDS server folder. Verify that the build was successful by ensuring the executable binary exists. Let's verify that the build was successful. Let's now configure Amazon Q CLI to use the MCP server. We start by editing the MCP configuration file. We are now ready to test our RDS operator MCP server. Start a chat session with Amazon Q CLI. Ask Amazon Q to list RDS instances in a specific region. Amazon Q should use the RDS operator MCP server to query the RDS instances and display the results. If you see a prompt asking you to allow this action, then enter T to trust this tool for the session. Amazon Q should use the RDS operator MCP server to query the RDS instances and display the results. Let's dive deeper to understand how this works by referring to the architecture diagram we saw earlier. When you query Amazon Q about RDS instances, it recognizes the RDS operator as the right tool for the job and initiates the RDS server using predefined configurations. It then sends your request with relevant parameters to the server, which communicates with RDS through the AWS SDK. After processing the response, Amazon Q formats the data and presents you with clear, actionable information. Try asking for more information about the instances. Amazon Q analyzes the response from the MCP server and provides the requested information. This concludes Lab 2. This lab demonstrated how MCP servers can extend Amazon Q's capabilities to interact with AWS services using the AWS SDK. We are now ready to move on to the next lab.
Hello and namaste everyone. I am Chintan Patel, Solution Architect at AWS. Today we are going to build an MCP server for S3 operator as a part of Lab 3. This MCP server enables the user to interact with an Amazon S3 services using a natural language commands, making it easier to manage S3 resources. For example, user can simply say list all my buckets or upload this file to my project folder. MCP server then would understand and execute those commands through the tool available to it. With high-level overview of lab, let's dive deep into the code. The initial part of the code does the importing of key components including AWS SDK and MCP server. Then it defines the structure which holds an information about S3. Then it implements the S3 operator which contains the client implementation. Then it has an tool implementation where it defines the code to connect to an S3 service and get required information. And then it have server implementations, and at end it combines everything and starts the MCP server. With that understanding of code, let's start working on building the S3 operator MCP server. For that, let's navigate to the required directory. Next, we would be building the server in the release mode. Now, this is going to take some time, so let's wait until it gets finished. Now that building has been completed, let's verify if the build was successful. Yeah, and it was successful. Now let's work on integrating it with Amazon Q CLI. For that, let's edit the MCP configuration file. Now let's test out our MCP server. In order to test, let's type in the command qchat. Now it will open the Amazon Q CLI, and here we can type in any question in a natural language. Now here is asking for a permission, so let's type in T to always trust. Now if you have another question, you can ask that question as well. So this is great, it is working. So let's review how it works in a background. So what happens that when you ask a question, Amazon Q recognize that it can use the S3 operator MCP server for this task. Then it starts an S3 server process using the command which is specified in mcp.json file. Then it sends out a request to the server with an appropriate parameters, for an example region. The server uses the AWS SDK to query the S3 service. Then the server processes the response and returns the formatted result. Now at the end, Amazon Q presents this information to you in a very user-friendly way. Thank you.
Welcome back. We are in the lab 4 of the workshop. Lab 4 is the final section in this workshop for building the MCP servers, focusing on the Postgres SQL operator server. This is the one that we are focusing in two major sections. First is setting up the Postgres server, and then using the operator, how we can interact with the user. This is the QR code for getting downloaded the sample code. So let's get this started. Before we dive into the console, just a visual walkthrough of how the sequence happens. So the user interacts with the Q client, Q CLI client. This information is sent to the backend LLM. We will be configuring the Postgre operator MCP server, where the questions will be redirected. This particular tool will talk to the Postgre server with the questions translated. We get the response back, and then the user gets the formatted results back from the queue. So this is a visual view that we are going to see in just a few minutes. I'm going to switch to the console here. Here are the few information that I have opened up prior to the lab. The first one you must have already seen in the previous labs, either in the calculator server, RDS server, or the S3 operator server. We have used the CloudFormation template, and we have the code server and the password. So I'm going to use this here. In addition to this code server, we are also going to use some of the database details, the endpoint information from the RDS database, which is already provisioned from the CloudFormation template. And also from the AWS Secrets Manager, we have the password information. So we are going to use the connection string, connectivity endpoint, as well as the secret to connect to the database. Okay, let's get this started. I have these two terminals open. The first terminal, I have already built the release, and after the successful building of the server, in the sample build MCP server folder, we will have the target subfolder and then the release and then the Postgres SQL Server deployment of the server operator. Once this is done, before interacting with the server, we are going to use the pSQL client to connect to the server. The first one is the password, the secret. This is the credential that was obtained from the AWS Secrets Manager. This information, we got it from the RDS client connectivity. We will use this command to connect to the server and then create a table and insert 1000 students information into the table. Okay, this is a prerequisite and this is outlined in the first section of the lab 4. Okay, we obtain the endpoint, we use the secrets manager, use this client connectivity, establish the connectivity, and then inserted the information. Okay, the next one part is how we interact with the operator server. Similar approach from the previous examples. The operator server code consists of different sections. The first one is importing the dependencies, defining the structures for the database tables, structure of the columns, and as well as storing the query results. Then this information holds the structures, holds the connection string, also the methods to create the connect to the Postgres client. This toolbox, you can think of the different tasks that we will be executing right now to the PostgreSQL, and this is a sample example to perform some basic CRUD operations, if you will. And as per your needs, you can continue to expand for your respective use cases. Here there are different tasks. One is identifying the schema, getting the schema information, and also having a read-only SQL query. Okay, these are the 3 simple tasks outlined in the lab here, and we will show it to you right now. I have a different chat window open to illustrate. The very first time you might initiate the queue chat, you will have to use a login. Once you select the login method, which is already part of the prerequisite of the lab, you use this URL to accept, and you will be logged in successfully. Using the queue chat, now we are interacting with this MCP server by issuing certain commands. Okay. So the first command we are telling is listing the tables. Queue client will reach to the LLM backend, and this knows that we have already have the MCP server, which is this one. And so using this server and the configuration that was done in the JSON file for the connectivity and then the argument, the connectivity string as an argument, it connects to the server, Postgres server, and it's able to list all the tables here right now. Okay. The next one, as we are continuing on, once it knows the server and identified the table information, we are continuing on the question to show the schema details, and it shows the various columns and the data types. We are continuing on our chat to list all the sample of the students sorted by name. Remember that we are not doing this by the SQL query. It then translates this automatically and responding the results back. Okay. Very similar to the previous examples, the user interacting with the MCP server with the natural language query. However, this information is translated accordingly as per the server translation. It constructs a query and then sends the results back to the user. Okay. This is a rundown of the lab 4 of this workshop. Going back to the slide here, as before, we will be concluding with a set of references here. The first one is this workshop that we just talked about. This is a QR code that contains all the 4 labs that we just saw. Second one is the Q developer user guide. This also has the links to the QCLI as well. And throughout this course, we have used Rust programming language. And so here is the QR code for the AWS SDK for the Rust. This successfully concludes our presentation for all the 4 labs of this MCP server workshop. Thank you once again from us to you for your time in spending us with for this lab. Happy building on AWS. Thanks a lot. Bye.